Hello everyone, this is Firoz Nadaf. In this video, I'm going to talk about the types of design that are encountered in the design of RCC structures. So basically, you have two types of design like singly reinforced beam and doubly reinforced beam when you're talking about beam. So here, the types of design I'm going to talk about is not singly reinforced beam and doubly reinforced beam. Okay, so whatever the types of design I'm going to talk about will occur in singly reinforced beam as well as in doubly reinforced beam. Okay, so basically we have three types of design in RCC structures in RCC beam: balanced design, under reinforced design, and over reinforced design. So I'm going to explain these types of design based on the terms used in working stress method. I will try to explain the concept of these design with the help of terms used in working stress method, but the same concept can be used in limit state method. The conceptual part is same, but the terms are different. So here I am going to use the terms by working stress method. In balanced design, you see, in the design of RCC beam, we have steel and we have concrete. So in this design, the steel and the concrete are so proportioned that the permissible stresses in the steel and the concrete reaches at the same time. If the design of beam is balanced design and if it is about to fail, the steel and the concrete will fail at the same time. That is why the design is called as balanced design, because steel and concrete will fail at the same time if it is about to fail. Okay, so you see, we have different terms in the balanced design. The depth of neutral axis is called as x balance, balanced depth of neutral axis. In some book they have written it as x critical, critical depth of neutral axis. The area of reinforcement here is called as AST, balance, associated with the balanced design, area of reinforcement associated with the balanced design. And you see the permissible stress in the concrete is sigma CBC. Sigma CBC means the permissible stress in bending compression. In beam, concrete is subjected to bending compression. Okay, and sigma ST is the permissible stress in the steel. When you draw the stress distribution diagram, sigma CBC in concrete and sigma ST in steel will reach at the same time. What is sigma CBC and what is sigma ST? I have explained the permissible stresses in the concrete and the permissible stresses in the steel in great detail in one video. I will share the link of that video in the description box. We have discussed balanced design. The other design will be discussed by considering balanced design. The balanced design will be acting as a benchmark for the discussion of other types of design: under reinforced design and over reinforced design. You see, under means the reinforcement that are provided in the under reinforced design are less as compared to the reinforcement provided in the balanced design. And when you draw the cross section and when you show the reinforcement, the AST will be less than AST balance. And when you discuss with respect to the permissible stress in steel will reach first and then it will reach in the concrete. The statement is not clear here. We can say that the permissible stress in steel will reach prior to that of concrete. And what is the meaning of permissible stress reach in steel? Means the full capacity of steel will be utilized. And if we say the permissible stress is reached in the concrete, it means that the full capacity of concrete is utilized. So here the full capacity of steel is first utilized, and then you can say after that the full capacity of concrete will be utilized. Okay, so since concrete is more and steel is less as compared to the balanced section, full capacity of concrete will not be utilized and full capacity of steel will be utilized at the time of failure. Now with respect to stress distribution diagram, I told you permissible stress in steel will reach first, sigma ST will come first, then at that time the stress in the concrete will not be sigma CBC, it will be less than sigma CBC. You can simply say sigma that is less than sigma CBC. You see, if the under reinforced design is about to fail, the steel will fail first prior to the concrete. And how does steel fails? It fails due to deformation. First, it has to undergo large amount of deformation and then failure occurs. You see, if the design of the beam is under reinforced design and if that beam is about to fail, it will have a ductile failure. It will not be the failure will not be a sudden, the failure will be a ductile. And you see, we are told that whenever you are designing a beam, you have to design it as a under reinforced design. You don't have to go for balanced design and over reinforced design. Always ensure that you are designing a beam as under reinforced design. Why they are saying this? Because you see, when you are designing a beam as under reinforced design, the failure, if it is about to fail, the failure will be ductile failure. The occupants can clearly see that beam is about to fail, and they can safely evacuate themselves from the building. Okay, so this is why we are encouraged, we are told to design the beam as under reinforced design, so that the occupants, those who are living in the building, can safely evacuate themselves from the building. We also have to see the strain distribution diagram of under reinforced design, and we will try to explain or try to compare this with respect to balanced design. You see, epsilon c is strain in the concrete and epsilon s is strain in the steel. What we say, the strain in the concrete in under reinforced design is less than the strain in concrete in balanced design. So you see, why this is, because in balanced design the stress is sigma CBC, and here in under reinforced design the stress in the concrete is less than sigma CBC. Stress is not more, stress is less. That is why the strain in the concrete is less. And with respect to steel, you see, sigma st is there in under reinforced design, and you also have sigma st in balanced design. The stress in the steel in under reinforced design and the stress in steel in balanced design are same. So you can say that the strain in steel in under reinforced design is equal to strain in steel in balanced design. So you see, what is happening here, the triangular portion below neutral axis will become larger and larger, and the triangular portion above neutral axis will become smaller, and there is an indication that the neutral axis is shifting upward. The depth of the neutral axis is becoming smaller. Okay, so the x is the actual depth of neutral axis, x balance is the balanced depth of neutral axis we discussed in the balanced design section. Now we will discuss over reinforced design. Over means the reinforcement provided are more than the balanced section. Here AST will be more than AST balance. The permissible stress in concrete will reach prior to that of permissible stress in the steel. If the over reinforced design is about to fail, the concrete will fail first, then steel, because concrete is less as compared to the steel. And you see how the concrete fail. Concrete is a brittle material, and when the failure of concrete occurs, it will be sudden. It will not show you any sign of failure. That is why designers are telling us that we have to avoid over reinforced design of beam. We only have to go for under reinforced design. If you go for over reinforced design, and if if the structure is about to fail, the occupant will not have any chance to leave the building. Okay, so it will not show you any sign of failure. So that is why we have to avoid the over reinforced design. Okay, so you see the stress distribution diagram of over reinforced design. Here sigma CBC will reach first, permissible stress in the concrete will reach first, then sigma there will be stress in the steel also, but it will be less than sigma ST at a time when you have sigma CBC. Okay, so we also have to see the strain distribution diagram. Here the strain in the concrete will be more, and the strain in the steel will be less as compared to the balanced section. And now you see the triangular portion above neutral axis is more, and the triangular portion below neutral axis is less, indicating that the neutral axis is shifting downward. Okay, here the depth of neutral axis is more than x balance. In case of under reinforced, it is less than x balance. I will show you, it is less than x balance, x critical. Okay, okay, so these are the comparison. uh, in case of balanced design, It is called as X balance XCR. So you see, we have to identify the type of design, whether the design is under reinforced design or over reinforced design. We can do that by comparing X with X balance. If X is less than X balance, then the design is under reinforced design. If X is more than X balance, then the design is over reinforced design. Okay, thank you for watching this video. Thank you very much.